In the realm of habitat construction and material science, understanding the properties and applications of different types of armatures is important. Each type of material serves a distinct purpose, and weighing their pros and cons can ensure the right material is selected for each project. XPS, or extruded polystyrene foam, is distinguished by its closed cell structure, making it an excellent choice for thermal insulation. This type of foam boasts superior moisture resistance, durability, and compressive strength. Although more expensive, it remains a popular choice for habitat structures. Here I am sketching out the features of a backdrop for a 10-gallon aquarium. This foam is also safe to use underwater in aquariums and is non-toxic. Both XPS and EPS can easily be cut with a hot wire cutter or knife. The surface should be sanded to remove loose pieces and in any area where the factory finish is still visible. EPS, or expanded polystyrene, is a lightweight rigid foam used in packaging applications. EPS is cost-effective and 100% recyclable. It does, however, have the possibility of releasing chemicals when exposed to heat. This sample will be shown again later as we convert this into a water bowl for reptiles. EPS can be smoothed carefully with controlled heat, but it can also melt very quickly. Be sure to remove all loose foam particles when finished. Expanding foam, known for its expansive properties once applied, is used as an insulator and gap filler. It sticks to literally everything and can be used to create lightweight armatures. Always wear gloves and never wear good clothes when working with expanding foam. Due to its porous nature, this foam doesn't hold up well when submerged in water. Allow the foam to fully cure prior to carving or introducing live animals. Expanding foam can often cure inconsistently with thick applications. For better results, rigid foam or cardboard can be used as a core to help minimize these inconsistencies. This sample will be used for a lightweight rock feature. Metal lath or fiberglass mesh make excellent reinforcements for concrete structures. When applying epoxy, no additional support is typically required due to its inherent strength. For best results, ensure that the mesh is properly anchored to the foam before applying the concrete layer. Here I'm using 18-gauge aluminum wire to make staples that will secure the mesh. In this sample, we are specifically adding reinforcement to the rock structure because it will be exposed to freeze-thaw cycles. The added reinforcement will help the structure endure extreme temperature variations, ensuring its stability. When cutting the mesh, be sure to wear long sleeves and gloves to avoid skin irritation. Fiberglass mesh is a lighter, safer option than traditional lath and is easier to work with. It will not rust and is the ideal choice for concrete applications which will be submerged in water or installed in humid and wet environments. The first method is using expanding foam, which hardens to create a strong bond between foam layers. It is essential to allow the foam to be fully cured before any additional work is done. The second method involves using 100% silicone. This adhesive is very effective but should only be used if no further cutting or shaping of the foam is required after gluing. Silicone provides a durable bond that can withstand various environmental conditions. This is a great method to adhere foam to glass or plastic. It's important to be mindful not to get any silicone residue on the face of the foam, as this may cause adhesion issues later. The third method is mechanical fastening, which includes techniques such as using wire or wood dowels to physically hold the foam pieces together. This works well when a temporary bond is needed or to hold the pieces while cutting. Cardboard can also be a great material for medium-sized, inexpensive, and hollow concrete structures. Here I'm using a box frame, which will then be wrapped with metal reinforcement. Lath is useful for complex shapes that span large distances without much support. Wearing cut-resistant gloves shape the material to your armature. This can be cut to size with sheet metal cutters or cutting pliers. Depending on the size and complexity of your project, it may be necessary to secure the reinforcement. Before mixing your concrete, always refer to the manufacturer's technical bulletin and SDS for the product you choose. It is recommended to add chopped alkali-resistant fiber to the base coat of concrete. When applying the stucco mix, I like it to be clay-like and a little on the wet side to prevent crumbling. Gently apply the mix with the palm of your hand, being sure to press it firmly into the reinforcement, but not hard enough to push it all the way through. As with all cement-based products, the material should be allowed to cure for a minimum of 28 days prior to submerging in water. The toxicity of Portland cement to fish, when added to water, is attributed primarily due to the high or alkaline pH produced upon hydrolysis. Allowing the product to fully cure for 28 days greatly reduces the risk of changes to pH and allows the product to become non-toxic to terrestrial organisms. A few full water change cycles are still recommended once the concrete is added. Always check the pH prior to adding live animals. Once applied and the mix has had a few minutes to rest, scratch the surface of the base layer with a notched trowel or scarifier. This will provide a mechanical bond and help press the concrete into the metal support. This will then be followed by a layer of Terra-Tech for detail and texture. Terra-Tech could be used for the base layer as well, but being a specialty modeling concrete mix, it wouldn't be cost effective. Wrap the completed project with plastic wrap or moisture retaining cloth. If you live in a hot or dry climate, the concrete can be misted periodically for the first 8 to 12 hours to prevent cracking. Using PVC or polyvinyl chloride pipe is a great way to achieve realistic branches or vines efficiently and inexpensively. The lightweight nature of PVC and its resistance to moisture and decay make it an excellent choice for constructing intricate and durable structures. PVC pipe can be manipulated with heat to form organic shapes, creating realistic and visually appealing additions for both terrestrial and aquatic habitats. An added advantage is that PVC pipe can accommodate the running of wires or tubing, making it easy to integrate lighting, water features, or other utilities seamlessly into the structure, keeping them safe and concealed. Here I am sanding this PVC pipe with 100 grit sandpaper to create a mechanical bond. There should be no shine left of the factory finish. Always clean the PVC thoroughly afterwards to remove any dust or debris. At this point, either Terra-Tech or epoxy can be added directly to the pipe, textured and painted to create instant, stunning vegetation. Concrete should never be applied over a molded, flexible plastic structure without additional support. This includes polyethylene, polypropylene, polystyrene, and nylon. These materials alone provide little support and adhesion failure or cracking is likely. Epoxy clay, however, will stick to molded plastics, but be sure to sand and clean the surface first. Never apply concrete or epoxy clay over any rubber-based materials. This includes neoprene, latex, urethane, and silicone rubbers. Concrete and epoxy clay will not adhere to rubber of any kind, especially silicone. Silicone is unsuitable for the structural demands required for concrete applications, leading to potential failures in both integrity and safety. Some silicone also contains chemicals that will cause cure inhibition in concrete. Foam materials that are soft or flexible are inherently unsuitable for use as structural supports or armatures. Their lack of rigidity compromises structural integrity. Furthermore, soft foam can be made from hazardous chemicals, posing unnecessary health risks. Due to their buoyant nature and chemical composition, they are wholly ineffective for underwater applications. The last group of incompatible materials includes glass, polished metal, wax, and many types of wood. We will not be covering wood in this video, as it is typically used to build the actual enclosure housing rather than the individual environmental components, and is typically not suitable for many applications. We will make a video in the future for large DIY ponds that are framed from wood.